today's most advanced cycloidal propulsion systems, each blade acts like an independent engine, adjusting its thrust direction over 1,000 times per second. This stands in stark contrast to traditional helicopters, which rely on mechanical linkages and swash plates, systems that introduce delays and restrict agility. Cycloidal designs bypass those limitations entirely, giving each blade full control authority in real time. The real engineering hurdle lies in synchronizing all those blades while keeping the aircraft stable. Each one has to respond to flight control commands within milliseconds, constantly adjusting based on the position and angle of every other blade. Decades ago, this kind of coordination was simply impossible. Now, thanks to modern servo motors, it's not only possible, it's precise. These small motors make constant micro-adjustments, guided by sensors and flight computers. As the system tracks changing forces, pilot input, and balance, each blade adjusts its angle on its own, in real time. What used to be mechanically impossible is now fully programmable. Here's a simpler way to picture it. Think of invisible hands pushing the aircraft from all sides, able to change direction instantly. A traditional helicopter tilts its entire rotor disc to move forward or sideways. Cycloidal propulsion skips that step. It doesn't need to tilt the aircraft at all. Instead, it adjusts the direction of thrust by changing blade angles mid-rotation, giving it full control without moving the body. It's not just better performance, it's way quieter too. Traditional helicopters make loud, slapping sounds because their blades create sharp pressure waves as they slice through the air at high speeds. Cycloidal rotors move more smoothly, with less turbulence and steadier blade speeds. That means a much quieter ride, which is crucial for flying in cities. They're also safer. In a regular helicopter, if the main rotor fails, it's usually a disaster, but cycloidal aircraft are designed with backups. If one rotor stops working, the others can take over and still land safely. These systems can do things traditional helicopters just can't. They can slide sideways through tight spaces, spin in place, and switch directions without needing to move forward. That kind of control is perfect for crowded city skies. This is a complete rethink of what rotorcraft can do. The theory is sound and the benefits are obvious, but now the question is whether the engineering can scale, whether these machines can move from promising prototypes to real-world aircraft. Austrian startup Cyclotech has turned theory into reality with a working prototype. The aircraft weighs just 83 kilograms and uses 4 spinning cyclorotors mounted on a lightweight carbon fiber frame. Each rotor spins at up to 3,100 RPM, adjusting thrust direction in real time. In 2023, Cyclotech raised over $20 million in funding and received approval from the European Union Aviation Safety Agency for outdoor test flights. Indoor tests have already shown smooth, controlled hovering and directional movement. But major hurdles remain. Nearly half of the aircraft's mass comes from the rotors alone. Their mechanical complexity, packed with the servo motors and moving parts, adds significant weight, which hurts energy efficiency and flight performance. Power use is another concern. Cycloidal systems require constant, precise adjustments to each blade, meaning the servo motors are always active. This continuous energy draw limits battery efficiency. Each rotor also demands precision-built components that must work in perfect sync, making cycloidal systems much more expensive than traditional rotors. Experts estimate mass adoption is still 5 to 10 years away. Engineers need time to reduce weight, improve power use, and simplify manufacturing before the technology can scale. For over 80 years, helicopter design has followed the same basic formula, but cycloidal propellers offer the first real departure from that model, an innovation with proven success at sea and rapidly expanding interest in the air. What happens next hinges on overcoming 3 key challenges: weight, efficiency, and cost. These aren't dead ends. They're engineering problems with clear paths to solutions. If progress continues, the next decade could mark a turning point in rotorcraft history. The technology works, investors are backing it, regulators are starting to engage. Whether city skies will soon echo with the soft hum of cycloidal aircraft or continue to rumble with the roar of traditional helicopters depends on how quickly those final obstacles are resolved. For the first time in generations, we're seeing a true shift in how rotorcraft are designed and what they can do. This change is real, it's happening now, and it can transform flight as we know it. If you found this breakdown interesting, drop a like, share your thoughts in the comments, and subscribe for more deep dives into the tech reshaping our world.